Hello everyone, I am Mr. Swapnil Joshi, proprietor of Joshis classes. We are going to take topic today from engineering mechanics. Name of the chapter is friction and name of the topic is belt friction. 101% sure shot question for university examination as well as examination conducted by all other autonomous colleges affiliated to university. So, let us see first concept regarding belt friction and then we will solve certain examples on belt friction. So, see this one by one. So, first of all we are going to see what is the meaning of belt friction. Whenever we wrap any belt along a pulley or whenever we wrap cable along the pulley or drum, then there is always a friction between string or cable and drum or pulley. So, there will be either drum or pulley or there will be string or cable. So, see this diagram. In this diagram, rotation of the drum or pulley is taken in clockwise direction. In all earlier chapters, we were considering the tension on either side as T only, because we were neglecting friction between the pulley and string in all other chapters. But now we are going to consider the friction between string and pulley. Let us see one by one. So, consider a pulley or drum rotated in clockwise direction. A cable or a string passes over it as shown in the figure. So, whenever there is a friction, we have to consider coefficient of friction. So, let us assume that mu be the coefficient of friction between the cable and pulley. Now, because of the friction, tension on either side must be different. One should be greater and other should be smaller. Clear cut we can see from the figure, if the rotation is clockwise, so T2 should be greater than T1, and since T2 is greater than T1, we have to give certain names for this T1 and T2. So, why T2 is greater? Because rotation is clockwise. If we consider anti-clockwise rotation with the same diagram, then in that case T1 will be greater than T2. T2 is called as tension on tight side and T1 is called as tension on slack side. T2 is greater than T1 must be remembered. Let the pulley be in contact with the belt, or we can say that belt be in contact with the pulley from A to B as shown in the figure. Observe that there is a contact between the belt and pulley only from A to B. So, that angle is denoted by beta, and this beta is nothing but corresponding central angle of that arc, and that angle is called as lap angle. So, whenever we consider the angle of contact, or we can say that angle through which belt is in contact with the pulley, that angle is called as a lap angle. Beta is the standard letter and it is always to be expressed in terms of radian. Now, we can see that this relation between these two can be given by two different equations. First one is log of T2 upon T1 is equal to mu beta, and if you take anti-log on both sides, we get T2 upon T1 is equal to e raised to mu beta. So, here again I am telling you that beta should be expressed in terms of radians. Now, in these two equations, if mu is unknown, if beta is unknown, it is better to use equation of ln, equation of log, and if T1 or T2 are unknown, in that case better to use second equation. So, this is the concept which is to be used to solve the examples. So, it is very simple that we just have to remember the concept of the lap angle, concept of tension on tight side, tension on slack side, along with the formula ln T2 upon T1 is equal to mu beta, or another form is T2 upon T1 is equal to e raised to mu beta. So, let us consider the example number 1. So, see that determine the minimum coefficient of static friction between the rope and fixed shaft as shown in figure to prevent the unbalanced cylinder from moving. So, read the example carefully first, that is we have to find out coefficient of friction between rope and that shaft. So, let us see this diagram is given. So, on one side 100 Newton cylinder is attached and other side 50 Newton. So, common sense is that 100 Newton is greater than 50 Newton. So, we have to consider T1 and T2 accordingly. Now, whenever we solve the example, in some examples of this belt friction, we can draw FBD of this. FBD means, in short, we have to show the front view of this figure if the figure is given in 3 dimensions in this manner. So, see that this question figure is there and we are going to draw FBD of this. So, FBD can be drawn very in simple manner, in this manner. From front side, shaft is going to see in the form of circle, and since 50 Newton and 100 Newton are vertically downward, we can show that 50 Newton in this manner and 100 Newton in this manner. From figure it is very clear that pulley is in contact with the belt for half of the circle, means semicircle, and angle of the semicircle is pi. And now here T1 and T2 we have to select. So, let 100 Newton be the tension on tight side, it has to be, since it is a greater than 50 Newton and 50 Newton is tension on slack side. So, naturally T2 is equal to 100 Newton and T1 is equal to 50 Newton. From figure it is very clear that beta is equal to pi or 180, but whenever we do the calculation of log or e raised to mu beta, we have to write down beta in terms of radian only, means we have to consider pi. Now, what is unknown? Mu is unknown, and that is why we have to use equation of log. So, using ln T2 upon T1 is equal to mu beta. Just substitute the value, T2 is equal to 100, T1 is equal to 50, and then mu into pi. Do the calculation using calculator, so that we get coefficient of friction as 0.2206. It is always better to write down answer with 4 digits. So, very simple example from examination which is completed. Now, we are going to take example number 2. So, see this example, a force P is equal to mg upon 6 is required to lower the cylinder with the cord making 1.25 turns around a fixed shaft. Determine coefficient of friction between the cord and shaft. So, we can see that question is same as that of earlier, here also we have to find out mu, and that is why here we also have to use same concept as that of last example. Let us see this figure now. What is the difference here now? Instead of giving lap angle directly, they have given number of turns. What do you mean by number of turns? If you wrap around a string around a shaft for one round, we can say that one turn is completed. In the same manner, instead of giving one turn, 1.25 turns are given. So, we have to use the relationship for that. Now, in this particular example, since lap angle is given directly in terms of number of turns, no need to draw FBD. So, let us see the solution of this, and for solution, see this diagram. Cylinder of mass m is given. So, we have to convert that mass in terms of weight. We know that W is equal to mg. So, weight of the cylinder is equal to mg. From the other side, the force is given as P, mg upon 6. Okay. So, given P is equal to mg upon 6. Now, compare that. Weight of the cylinder is mg and given value of P is mg upon 6. So, by comparison, it is very clear that mg is means weight of the cylinder is greater than given value of P, and therefore, we have to consider T2 as means tension on tight side as mg and tension on slack side as P. P means mg upon 6. Now, we have to convert turn in terms of angle. One turn means one rotation is completed, and you know that one rotation means equal to 2 pi radian, and therefore, we can find out 1.25 turns is equal to 1.25 into 2 pi. It means that it is equal to 2.5 pi radian. In short, we can say that lap angle is, that is beta is equal to 2.5 pi radian. Same as that of last example, since mu is unknown, we can use the formula ln T2 upon T1 is equal to mu beta. Substitute the values of T1 and T2. T1 is equal to mg upon 6, T2 is equal to mg, and beta is equal to 2.5 pi. Clear cut we can observe mg and mg gets cancelled. You can shift 2.5 pi to other side and find out the value of mu. So, we get after calculation value of mu as 0.2281. Again, it is better to write down the answer in 4 decimals. So, first two questions almost of the same type. Now, let us proceed for example number 3. See the difference in the example now. A cable is passing over the disc of belt friction apparatus as shown. If the weight of the block is 500 Newton, determine the range of force P to maintain the equilibrium. So, what is the difference in the example? Now, the difference is we have to find out range of force P. From figure mu we can see 0.3 is given between that cable and pulley, or we can say disc. What is the meaning of range of values? The meaning of range of values that we have to consider clockwise rotation of this disc as well as anti-clockwise rotation of the disc. Again, no need of drawing FBD, because clear cut we can see that cable is wrapped around the disc for half of the circle. In other words, lap angle must be equal to pi. So, this is the original diagram, and now we will see the solution. As I told you earlier, the range of P for equilibrium can be found out by considering clockwise and anticlockwise rotation of the pulley. As far as values are concerned, which are common for both the parts, that is weight of the block 500 Newton, number 2 that is mu 0.3 and beta pi. So, these values are same for both the parts of example. Both the part means clockwise rotation as well as anti-clockwise rotation. Now, let us consider first clockwise rotation of this particular apparatus. So, for this rotation, P is the force on tight side. It is a common sense that whenever rotation is clockwise, value of P should be greater than weight of the block, and therefore, we can say that P is greater than W. We can assume tension on tight side as P means T2, tension on slack side means T1 is equal to W. And for calculation, we can also find out separately mu beta. That is easy for us for doing a calculation 0.9424. Now, here what is unknown? P is unknown. So, instead of using the equation of log, it is better to use second equation, which is in terms of exponential term, and here we are going to use now T2 upon T1 is equal to e raised to mu beta. Now, T2 means P, T1 means W, and mu beta means 0.9424. Just substitute in this particular equation. So, P upon 500 is equal to e raised to 0.9424. You can transfer that 500 to other side, and also we can find out the value of e raised to 0.9424 separately. It comes to be 2.5661, and then multiply these two values to get final answer of P as 1283.05 Newton. So, for clockwise rotation, we got the value of P as 1283.05 Newton. Now, in the same manner, we have to consider anticlockwise rotation. So, what will be the change in case of anticlockwise rotation? So, whenever rotation is anticlockwise, value of P should be less than weight of the block, and therefore, for this rotation W is a force on tight side and P is on slack side. Therefore, we can say P is less than W. Now, since P is tension on slack side, we can call now T1 is equal to P and T2 is equal to 500 Newton, that is W. Mu beta will remain same as that of earlier part 0.9424, and again by using the same equation T2 upon T1 is equal to e raised to mu beta. So, put the values of T2 and T1. So, let us see what you get. 500 upon P is equal to e raised to 0.9424. We have calculated the value of exponential term in other part, earlier part. So, do the cross multiplication and find out the value of P in this case. Now, value of P in this case is 194.83 Newton. Since the range of values of P is asked to calculate, we have to give the answer in terms of range. So, range of these values of P can be written in this manner: 194.84 less than or equal to P, less than or equal to 1283.05 Newton. In short, this system will remain in equilibrium only when the value of P is in between these two extreme values. So, this is called as range of values. So, one more example is completed. Now, we will see that in next example what is the difference. Let us take now example number 4. Determine the range of P for the equilibrium of the block of weight W as shown in figure. The coefficient of friction between the rope and pulley is 0.2. So, see, example is same as that of earlier. Again we have to find out range of values of P, and range of values of P means here also we have to consider clockwise as well as anti-clockwise rotation of this drum or pulley whatever is given. So, first of all we are going to find out the value of beta now. What is the observation? W is from the extreme left end and P is attached to extreme top. So, if you draw a normal from that point of tangency, you can observe that pulley is in contact with the belt for 1/4 of the circle, and if it is for 1/4 of the circle, beta is 90 degrees, or we can say that beta is equal to pi by 2. So, let us see the solution. First of all we have to write down the value of beta pi by 2, then you can take given value of mu 0.2. For sake of convenience let us find out mu beta 0.2 into pi by 2, that comes to be 0.3141, and then same as that of earlier example, the range of P for equilibrium can be found out by considering clockwise as well as anti-clockwise rotation of the pulley. Exactly same example. Let us see that first clockwise rotation. So, for clockwise rotation P must be greater than W, and for this P is greater than W. So, we can say that P is the force on tight side and W is the force on slack side. So, therefore, P is greater than W. As P is on tight side, we can take T2 is equal to P and T1 is equal to W. Use the formula T2 upon T1 is equal to e raised to mu beta. Now, here exact value of W is not given. So, we have to give the answer of P in terms of W only. So, we can replace T2 by P and T1 by W, and e raised to mu beta is e raised to 0.3141. Find out the value of that exponential term, then transfer W to other side, so that we get the value of P as 1.3690 times W. Exact value of W is not given, means we have to give the answer in terms of W only. So, this is one value that we got. Let us see now another value, and for another value we have to change the direction of rotation. Let us consider now anti-clockwise rotation. Now, when we take anti-clockwise rotation, W will become a force on tight side and P is on slack side. Okay, it means that whenever W is on tight side and P is on slack side, W must be greater than P, and therefore, as per our notation, T2 is equal to W, T1 is equal to P, mu beta remains same. Again, by using same equation, T2 upon T1 is equal to e raised to mu beta, put the values of all. T2 is nothing but W, T1 is P, and e raised to 0.3141. So, simplify it. We have to transfer exponential term to other side, and then we will get the value of P as 0.7304 times W. So, whenever we consider clockwise rotation, we get greater value of P, and for anti-clockwise rotation we get smaller value of P. Again, answer to be given exactly in the same manner as that of last example, since the range of P is asked to find out. So, range of the P can be written in this manner. So, 0.7304 times W less than or equal to P less than or equal to 1.3690 times W. So, these are two examples of the same type. In next example, we are going to understand new concept now. Let us take now example number 5. Two cylinders are connected by a rope that passes over two fixed circular rods as shown. Knowing that the coefficient of static friction between the rope and the rods is 0.40, determine the maximum value of M for the equilibrium. So, we can see that here there are two rods, instead of pulley or instead of drum, rods are given. Rods are circular in shape B and C, and one common string is passing from first to last point. So, ABCD is the total length of the string. See the figure, instead of pulley or drum, rods are given, and then we can see that one common string is passing from A to D. Block A is having a weight of 50 kg, and we have to find out maximum value of that mass M. Okay. So, how to solve? Let us see the solution. Now, as we want to find out maximum value of M, it should be taken on tight side, and therefore, here we are going to consider now T1 is equal to 50 kg and T2 is equal to M kg. Actually, T1 and T2 are forces, must be expressed in terms of Newton, but in this particular topic we are taking the ratio of T1 and T2, and therefore, no need to convert that in terms kg in terms of Newton, because if you convert that by using the gravitational acceleration, that factor g will get cancelled while taking the ratio, and that is why T1 and T2 are taken in terms of kg and not in Newton. Now, what about beta? We can see that since here string is passing combinedly from rod B to rod C, if you consider rod B, situation is exactly same as that of last example, that rod is in contact with the cable for 1/4 of the circle, means lap angle if you consider only B part, that is pi by 2, and for C again we can see angle is pi by 2. Since we are considering complete example, we can take total beta 90 plus 90, that is 180 degrees or pi radian. So, here angle of contact between the rope and two rods directly we can combine in terms of pi radian, and now just by using the formula T2 upon T1 is equal to e raised to mu beta, we can find out the value of that M. So, just by replacing T2 by M, T1 by 50 and e raised to mu beta, we can calculate mu beta separately if you want, like our earlier example, or you can do direct calculation, whatever is suitable to you. And after calculation we can find out the value of M must be greater than 50. See that value of M is 175.68 kg. So, we can observe as far as calculations are concerned, less calculations are there compared to other chapter, or even we can say other topic of friction. So, this must be done perfectly so that you can solve the example in minimum time to get full marks. Let us take now last example, example number 6. A block of 10 kg hanging through an inextensible cable and kept in rest by applying a force of magnitude F is equal to 1.5 kg on other side of the cable, which is passing through the rough pulley as shown in the figure, whose μs is equal to 0.30. Determine number 1 lap angle between cable and pulley and number of turns required to bound the cable on pulley. Now, lap angle and number of turns are nothing but one and same, just expressed in other units. So, here in short we have to find out lap angle. Once you get that lap angle in terms of radians, can be converted in terms of number of turns easily. See this diagram. Now, in this case we need not find out lap angle with the diagram, because that but it is very clear that it should be greater than 90 degrees from this particular figure. Once again we can say that 10 kg is given, as we are going to take the ratio of two forces T2 and T1, no need to convert kg in terms of Newton. Let us see now solution. From figure it is very clear, T2 is equal to 10 kg, T1 is equal to 1.5 kg. We know that T2 is always greater than T1, and that is why 10 should be T2 and 1.5 must be T1. Mu is given as 0.3. Now, here we want to find out the value of lap angle, and that is why we have to use the formula related to log, and that is log of T2 upon T1 is equal to mu beta. Just put the values of T1, T2 and mu, so that we will get the value of beta as 6.3237 radian. If you want, you can convert that in terms of degrees as well by using the concept that 180 degree is pi radian, or you can directly use calculator to convert radian in terms of degrees. And now here question is, we have to find out lap angle, and number 2 was to find out the number of turns. Equation we already used in our earlier example, that is 1 rotation means 1 turn, 1 rotation means 2 pi radian or 360 degrees. So, here we can say that 360 degrees is equal to 1 turn, but total number of degrees for this example is 362.321. So, here 362.321 is equal to 1.006. Simply we have to take the ratio of 362.321 upon 360. So, that gives you number of turns as 1.006. So, we have covered all important examples of belt friction, so that you can ensure full marks from this particular topic. Thank you so much.